section 8.3 is on special angles. Not just any angles, special angles. Now, this will be another topic that'll be very useful in grade 11 and 12, but I think it's very worthwhile to take a look at it in grade 10 as well. So this should look familiar, this table here. We filled it in last time. So we have the different angles, and then we have the sine amount, the cosine amount, the tangent amount. For example, sine of 30 degrees is 0.5, right? Now, why have I put some in black and some in red? Believe it or not, it's not just to make it pretty. I've actually done this for a particular reason. The reason is because all the answers in black here, these are all exact answers. 0, that's an exact amount. 0.5, that's a half, that's an exact amount. 1 is an exact amount. These red numbers here, these are not exact amount, these are approximations. How come? Well, let's take a look at one of these. Let's try cosine of 30. We have that the answer is 0.8660. So let's try it. Cosine of 30. So I go to my calculator and I put cosine of 30, and I get 0.8660254. Oh, so there's actually more decimal spots than what I have written. I should also have a 254. If I write that, will it then be exact? No, because it actually goes on and on forever. This decimal goes, and it's infinitely long, and it never repeats. So the best we can do is write down an approximation. Even your calculator, even if your calculator showed 30 spots, it's just an approximation. What we're going to learn to do today is to get exact values for this whole table here. And the way we're going to do that is we're going to look at two triangles. The 45 degree, 90 degree triangle, and the 30, 60, 90 degree triangle. Okay? Alright, this 45 degree, 90 degree triangle. This is an isosceles triangle. What does that mean, isosceles? Do you remember that? It means that two sides are exactly the same length. Which sides would be the same length? Well, not the hypotenuse. That's much bigger, or at least a little bigger than these two. So these two must be the same length. Let's call both of those 1. This has a length of 1, and this has a length of 1. You don't have to. You could call them 5 and 5, or 12 and 12, whatever you want. But 1 and 1 makes it the easiest. Now, if we want to know, first of all, if this is an isosceles triangle, and two sides are the same, you might not know this, but it also means that two angles are the same. Now, which angles are the same? The ones that are across from the congruent sides. So these sides are the same length, right? Which angles are across from them? This angle's across from this side, and this angle's across from that side. So that means that these two angles here are exactly the same amount. Now, how much must they be? If this is 90 degrees here, how much is left over for the rest of the triangle? Well, remember, the whole thing has to be 180, so if we take away 90, we're left with 90. These two together have to equal 90, and they're the same amount, so how much is each one of those? Each one of them must be 45 degrees. Okay, so that's why it's a 45 degree, 90 degree triangle. Alright, and what we've done so far is we've called the two sides here 1 and 1. So we need to know how big is the hypotenuse. How are we going to do that? We're going to use the Pythagorean theorem. And the Pythagorean theorem says that a squared plus b squared equals c squared. And it is the hypotenuse we want to know, so we want to know the biggest side. So we're going to add. We're going to have 1 squared plus 1 squared equals c squared. 1 squared is 1. 1 squared is 1 equals c squared. So c squared is equal to 1 plus 1, which is 2. Which means c is equal to the square root of 2. Now, before you go reaching for your calculator, this is an exact amount. Square root of 2 is an exact amount. This side right here is the square root of 2. If you take your calculator and put in your calculator square root of 2, there it is, square root of 2 right there, you get 1.414213. Is that an exact answer? No, that decimal goes on and on forever, and it never repeats. So if you want an exact answer, you leave it as the square root of 2. And that's what we're going to do. Now, why do we do this? Because now we can figure out what is sine and cos and tan of 45 degrees. How do we do that? Well, let's take a look. Sine of 45 degrees. Choose one of these two angles. It doesn't matter which one you use. I'm going to use this one. Why not? If you want, use the one up here, but I'm going to use this one down here. If I want to know what sine 45 is, I know that sine 45 means, or I know that sine means opposite over hypotenuse. What's opposite from here? 1. What's the hypotenuse? Root 2. So sine 45 equals 1 over root 2. What's cos 45? Cos 45. Cos is adjacent over hypotenuse. Adjacent is 1 over root 2. What's tan 45? Tan 45 is its opposite over adjacent. Opposite is 1 over adjacent is 1. 1 over 1 is 1. Oh, okay, so up here in the table, instead of having 0.7071, 0.7071, and 1, we could have 1 over root 2, 1 over root 2, and 1. Those are exact answers, whereas these are not exact answers. Okay, I'm going to fill this in for you. Well, we could do it now, I suppose. So what we've done so far is we have eliminated this, and instead we have written in 1 over root 2. And tan 45 is 1, and we already had that. It's already an exact answer. We don't need to change it. Okay, great. We now have all those. Now what we need to do is figure out the 30 and 60. So we have to go look at another triangle. This time we have an equilateral triangle. We're starting with an equilateral triangle. What does equilateral mean? It means all the sides are the same. Now you're probably thinking what you're going to do is you're going to name the sides 1, 1, and 1. It actually makes it a little bit easier if you call them 2, 2, and 2. And I think you'll see why in a second. You can call them anything you want. You call them 3, 3, and 3, 16, 16, 16. I think the easiest way to do it is to call it 2, 2, and 2. Alright, now, if this is an equilateral triangle, how much is each one of these angles right here? You have 3 angles, they're all exactly the same, and we know that the angles in a triangle add up to 180. So 180, what do we have to do? Divide it by 3, since there's 3 of them. Each of them must be 60 degrees. This is 60 degrees, this is 60 degrees, and this is 60 degrees. That's an equilateral triangle. It's always 60, 60, 60. So now what we're going to do is we're going to cut this thing. We're going to cut it straight down. This is probably going to be hard for me to show, but straight down from the highest point down. So it makes a right angle right here. This is a right angle. And what I'm going to do now is I'm going to redraw this triangle here, just this side of it. Right? See how I've kind of cut the big triangle in half? I'm just going to redraw this right-hand side. Or you could draw the left-hand side if you want to. It doesn't matter. So, what do I have? I have a right angle. How much is this right here? Well, it didn't change. It's still 2. How much is this right here? It's not 2. 2 is from here to here. So from here to here is half as much. It's only 1. What's the angle right here? That didn't change. It's still 60. If this is 90 and this is 60, how much must this be? 30. Or another way you could look at it is, it was 60 up here, but you cut it in half, so it's now 30. Okay, so we have a 30, 60, 90, 30, 60, 90 triangle. We know this side, we know this side, we don't know this side. How are we going to get it? Pythagorean theorem. But this time you know the hypotenuse, so you're going to square both of these. You're not going to add them. You already know the biggest side. You need a smaller number, so you're going to subtract them. And don't call it c squared, call it a squared or b squared. I'll call it a squared. So this side here, if I call it a, is equal to 2 squared minus 1 squared. So that's 4 take away 1 equals a squared. 3 equals a squared, which means a is the same as the square root of 3. Don't put the square root of 3 in your calculator. You're going to get some crazy number that's not exact. Square root of 3 is an exact answer, so we'll put the square root of 3 here. Now we can get everything we want. We can get sine 30 degrees, we can get cos 30 degrees, we can get tan 30 degrees, we can also get sine 60 degrees, we can get cos 60 degrees, and we can get tan 60 degrees. So let's do all those. Won't take us long. Okay, sine 30. We look from the 30-degree angle, which is right here. Sine is opposite over hypotenuse. Opposite's 1, hypotenuse is 2. 1 over 2. We already knew that. Look in your table. It says 0.5. Cos 30 is adjacent, which is root 3, over hypotenuse, which is 2. Tan 30 is opposite, which is 1, over adjacent, which is root 3. Okay, sine 60. Now we look from the 60-degree angle. So we're now looking down at this angle, and I'm asking myself, sine 60, that's opposite, which is root 3, over hypotenuse, which is 2. Cos 60 is adjacent, which is 1, over hypotenuse, which is 2. And tan 60 is opposite, which is root 3, over adjacent, which is 1. Root 3 over 1 is just the same as root 3. Great, so we can go back to our table and we can fill all these things in. Instead of having cosine 30 is 0.866, we can put cosine 30 is root 3 over 2. Okay, finished. Okay, now you're probably thinking, I do not want to have to memorize this whole table, and I don't blame you. That's quite a bit of memorizing. I'm going to show you an easy way to memorize this. But before I do that, I need to show you one other thing. 1 over root 2 right here is exactly the same. You'll learn this later in this course. 1 over root 2 is the same as root 2 over 2. 1 over root 2, again, is the same as root 2 over 2. Now, you're probably saying, great, he wants us to memorize this. He says he's going to make it easy for us, and he just added something else to the equation here. So I'm going to show you how easy you can do this using a little pattern. So I'm going to get rid of all this and show you what you can do. Here's what you do. Start with sine and put everything over 2. This is 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 over 2. Now go 0, 1, 2, 3, 4. So far so good? Then just put a radical sign on the top of each thing. So you actually have root 0, root 1, root 2, root 3, and root 4. Now let's see which ones we can simplify. Can you take the square root of 0? Sure, the square root of 0 is 0, and 0 over 2 is just 0. That one's done. Can you take the square root of 1? Sure, the square root of 1 is 1, so you get 1 over 2, or 1/2. Can you take the square root of 2? No, you can't, so you just leave it. I mean, I don't know why I'm rewriting it, but just put root 2 over 2. Same with root 3. Can't do anything with it, so just leave it. Root 3 over 2. Can you take the square root of 4? Sure, the square root of 4 is 2, so you get 2 over 2, which is the same as 1. That's not so bad. Now, if you want to do cosine, you know what you do? If you remember from last day, all you do is you take these answers, just reverse them. Instead of 0 here, you put 0 at the bottom. Instead of 1/2, 1/2 goes here. Root 2 over 2 stays the same for this. Root 3 over 2 goes up here, and 1 goes up there. Great! Now for tangent, the way you can get tangent is you remember that tan is equal to sine divided by cos. So you're going to take this one and divide by that. 0 divided by 1 is 0. No problem. Skip this one for a second. This one, root 2 over 2 divided by root 2 over 2. Well, if you're dividing the same thing, it's going to equal 1. This one, 1 divided by 0. You can never divide by 0. We're almost done. Last thing we have to do. We're going to divide 1/2 divided by root 3 over 2. How do you divide fractions? Keep the first one the same, change to multiplying, and flip. Hey, if you've got a 2 on the top and a 2 on the bottom, you know what you can do? Cross them out. So what are you left with? 1 over root 3. Okay, good. And the last thing we have to do is this one. We're going to have to do root 3 over 2, that's our sine value, divide it by 1/2. Again, we're going to keep the first one the same. We're going to flip the second one, and you can get rid of the 2's. So what you're left with is root 3 over 1, which is just root 3. There you go. We've done. We've got the whole table filled in. Now, if you want, you can go ahead and just memorize this whole table, but I think it's easier just to remember this pattern here, reverse it here, and then do sine over cos to get this one. By the way, if you do want to have the whole table complete, you might want to write that root 2 over 2 is the same as, how should I put this? I'll put or 1 over root 2. And that also goes here, or 1 over root 2, because that answer will probably show up in your book sometimes. I don't want you to think you got them all wrong. Alright, so now all you're going to do is use this table to answer some questions here. So for example, if it says cos theta, it says find the exact value of each expression if theta equals 30 degrees. So if it asks for cos theta, it's asking you for cos, what's theta? 30 degrees. What's cos 30 degrees? Well, if you've memorized it, great. Otherwise, check your table. Cos theta is root 3 over 2. Root 3 over 2. See, we're not going to use our calculator for this page at all. You need to be able to generate this table on your own, okay? I won't give it to you. You have to be able to write that down on a piece of paper or something, or just memorize the whole thing, but I'd rather be able to generate it. It's easier, I think. Sine 2 theta. Well, that means sine of 2 times theta, and theta is 30. So it means sine of 2 times 30 is 60. Sine 60, if you haven't memorized it, you probably haven't yet. Sine 60 is root 3 over 2. Again, same answer. Root 3 over 2. Okay, next one. Cosine squared 2 theta. Remember, that is the same as cosine 2 theta all squared. I know it's weird how it's written like that, but that's what that means. So that means cosine of 2 times theta is 30, right? All squared. That means cosine of 60 all squared. What is the cosine of 60? Well, look back at our table. Cosine 60 is 1/2. So cosine 60 is 1/2, and then we're going to square it. That means 1/2 times 1/2, or 1/4. If you want, you could spread the love here. 1 squared is 1, 2 squared is 4. Next one, cosine squared theta divided by 2. That's the same as cosine theta squared over 2. And what's theta? 30 degrees. So it's cosine 30 squared divided by 2. How much is cosine 30? Oh, we have it right here. Cosine 30 is root 3 over 2. So we have root 3 over 2 squared, and that's all over 2. That looks a little confusing, doesn't it? Okay, root 3 over 2 squared. You could spread the love here. So you have root 3 squared. Remember what root 3 times root 3 is? 3. Then you have 2 squared. 2 times 2 is 4. And that's all divided by 2. Let's make it 2 over what? Make it a fraction. 2 over 1. So now we can switch this to, since this means divide, let's make it a division of fractions. 3/4, keep that one the same. Turn it into a multiplication question. What do we do to this 2 over 1? Reciprocal, right? Always flip the second fraction. Sig it over 1 over 2, and if you multiply, you get 3 over 8. Alright, next, 4 sine squared 2 theta over 5. Wow, crazy. So this means 4, and then sine 2 theta squared divided by 5. Okay, 4 sine, let's just do this. 2 times, you know it's 30 degrees, so this means sine 60 squared over 5. How much is sine 60? Sine 60 is root 3 over 2. So we have 4 root 3 over 2 squared all over 5, which is 4. Again, spread the love here. Root 3 times root 3 is 3. 2 times 2 is 4 times 5. Oh look, when we multiply this 4 times 3/4, the 4's cross out because this is the same as 4 over 1, right? So 1 on top, 1 on the bottom, they cross out. What are you left with? 3 on the top, 5 on the bottom. Finished. Alright, here we go. Sine, this means 120 degrees minus, what's theta? 30 degrees. So this is the same as sine 120 minus 30 is 90 degrees. What's sine 90? Sine 90 is 1. The answer is 1. Okay, a few more and we're done. Sine squared 30, that means sine 30 all squared times tan 60 all squared minus cos 45 all squared. Okay, so we look up sine 30. I think we looked it up somewhere else here, didn't we? Oh, well, I'll look it up. Sine 30 is 1/2, so we get 1/2, and then we have to square that, times tan 60. Tan 60, you gotta love this table, root 3, you get root 3 there, so root 3 all squared, and then you're going to minus cos 45. Cos 45 is root 2 over 2, or 1 over root 2 if you want, but I'll put root 2 over 2. Root 2 over 2 all squared. Okay, 1/2 squared, spread the love, you get 1 over 4. Root 3 squared, that's root 3 times root 3 is 3. And then we're going to subtract root 2 over 2 squared, spread the love. Root 2 squared is 2, root 2 times root 2 is 2, and 2 squared is 4. Okay, got to multiply here. This is the same as 3 over 1. So 1/4 times 3 over 1 is 3/4. And then we're going to subtract the 2/4. Hey, we already have common denominators. Nice. 1/4 is our final answer. Next one, I'll do it in different colors because it's going to get kind of confusing here. 2 tan 60. Okay, well that's 2 times tan 60. We can look that up right now. Tan 60 is root 3. So 2 root 3 over 1 minus tan 60 squared. So let's say, oh, tan 60 we already looked up. It was root 3, right? Tan 60 up here is the same as tan 60 down here, but you have to square it on the bottom. Okay, so on the top we have 2 root 3. On the bottom we have 1 minus root 3 squared. That means root 3 times root 3, which is 3. Okay, on the top we have 2 root 3. On the bottom, 1 take away 3 is negative 2. Oh, we got a 2 on the top and a 2 on the bottom. You can cross them out. You're left with a negative sign. Just move it up. Negative root 3 is your answer. Okay, last one. Sine 60. We must have done that sometime along the way, but I'll look it up again. Sine 60 is root 3 over 2. root 3 over 2. I'm going to multiply that by cosine of 45. Cosine 45 you have right here. It's root 2 over 2. You can look in the table if you're not clear about that. Plus cos 60, I know we've done it somewhere. Cos 60 is right here. You get 1/2. So cos 60 is 1/2. And sine 45, have we done sine 45 somewhere along? Oh well, I'll go back and find it. Sine 45 is root 2 over 2. So make sure you follow BEDMAS, order of operations. You've got to get this answer, and then do the adding last, right? So in the first part we have root 3 times root 2. What you do there is you multiply the two numbers in the radical and keep a radical sign. So it's root 6 over 2 times 2 is 4, plus 1 times root 2 is just root 2, 2 times 2 is 4. Okay, since they have the same denominator, you can put it all over 4 and just put root 6 plus root 2. You can't add when they have different radicals like this. This does not equal root 8. You can multiply root 6 times root 2, it equals root 12, but you can't add it. So this is your final answer right there. Okay, we're done. Main thing here is I'd love it if you could memorize this table. It is going to come up time and time again in grade 11 and 12. Okay, thanks very much.